Assalamu alaikum. I'm Dr. Wael Muhammad, PhD in Applied Mathematics from Egypt for Edexcel AS Pure Math 1, Chapter 2, Quadratics. In the previous video, we talked in details about this chapter, but as a short summary before solving past paper problems, we have three main points. The first point is completing the square. If we have a quadratic expression like this, ax squared plus bx plus c, to complete the square, we need the coefficient of x squared to be 1. So we take a as a common factor, and then we have inside this bracket x squared plus b over ax, and keep c away, okay? And then equals a, and then big bracket. Inside this bracket we put small bracket squared here, of course, and then write the square root of x squared, which is x, and here half of the coefficient of x, which is b over 2a, and subtract the same quantity but square of it. If I write here 10, I must write here minus 100. If I write here minus 3, I should write here minus 9. And the main idea here is that if we expand this perfect square, this will include three terms: x squared, which is here, and then 2 times first times second, which is b over ax. But this perfect square included already the second term squared, which is b squared over 4a squared, and this quantity doesn't exist here. So we must subtract it again to keep the expression as it is, okay? And finally, expand this a again here, okay, and simplify this constant with negative b squared over 4a. The second point is the discriminant and types of solutions. For we know that the solution will be given by negative b plus or minus square root of b squared minus 4ac all divided by 2a. And since this quantity exists under the square root, it has a very important significance. We call it discriminant, and according to this value, we can determine the types of roots. So algebraically, if this quantity more than 0, then the positive sign here will give us a solution, and the negative sign will give us another solution. So we have two distinct real solutions. And graphically, if we represent the left-hand side here as a quadratic function, this curve will intersect x-axis into 2 points, which are called x-intercept, or called the roots of the function, or called the solutions of the equation f of x equals 0. In the second case, if b squared minus 4ac equals 0, in this case, the positive and negative here has no meaning because this quantity is 0. So we don't have except one solution, which is negative b over 2a. Okay, and in this case, graphically, the curve will touch the x-axis. Okay, will touch it, not cut it as in the first case. And the third case, b squared minus 4ac less than 0. Of course, algebraically, we can't take a square root of negative quantity, so we don't have real roots or real solutions in this case. And graphically, the quadratic curve will be below x-axis or up x-axis, but it doesn't intersect or touch x-axis, of course. Okay. The final point is how to sketch a quadratic graph, and we should follow 4 steps. The first one is to look at the sign of A. If it's positive, we will graph upward curve, or we say sometimes smile face. And if A is smaller than 0, we'll draw sad face, or the opposite will be downward. Number 2, put x equals 0 to get the y-intercept. And number 3, solving y equals 0 or f of x equals 0 to get the x-intercept or intercepts if they are exist, okay? And number 4, finding the turning point, or called vertex point, which has coordinates h and k. If we have roots, then the turning point will be halfway between two roots. If we have just one root, the curve will touch x-axis, and at this, the intersection point or the x-intercept will be the turning point. If we don't have roots, we can either completing the square or finding h to be negative b over 2a, and take this value and put it in the function to get the y coordinate of the vertex or the turning point. Let's go to the past paper problems. This shape has an area of 44 meters squared. Find the value of x. Very interesting problem. Of course, we will divide this area into two parts. The left part here is a square with side length x, so its area will be x squared. And the right part will be a rectangle with dimensions just here 1x and x plus 3. So to get the total area, we will write here x squared plus this x times the bracket, which is x plus 3, and the total area is 44. Expanding this, we have here x times x squared, and we have already x squared, so we will have 2x squared plus x times 3, we will have 3x. 44 will move to the other side, minus 44 equals 0. Then solving this equation, 2x plus 11 times x minus 4 equals 0. So either x equal minus 11 over 2, which is rejected because x here is a length. It can't be negative, but the answer here is x equals 4 centimeters. Solve the equation 5x plus 3 equals square root of 3x plus 7. Of course, we will squaring both sides to get the following. Squaring the left-hand side according to the perfect square expansion, 25x squared, we square the first, and then multiply 2 times first times second to be 2 times 5, 10, times 3, 30x, plus 3 squared, which is 9. And of course, when we square the right hand side, we will eliminate the square root to be 3x plus 7. Rearrange the problem here now. 25x plus 2 times x plus 1 equals 0. And in this case, either x equals negative 2 over 25 or x equals negative 1. But because we have a square root here, please try to substitute again to check that all values are accepted. So if we put x equals negative 1 in the left hand side here, 5 times negative 1 is negative 5. Negative 5 plus 3 is negative 2. The square root of any quantity can't be negative. So we must reject this value, okay? For x equals negative 2 over 25, times 5 would be negative 2 over 5. 3 minus 2 over 25 is a positive quantity, and we will accept the solution only. Exercise 2b. This trapezium has an area of 15 meters squared. Show that the height of the trapezium is equal to 5 square root of 5 minus 1 meter. Of course, we know that the area of the trapezium is equal to half the sum of two parallel bases, which is x plus x plus 10. So we can write 2x plus 10 multiplied by the height, which is 2x, equals the area, which is 50. Okay, so we can cancel this 2 with this half here, and we can divide by 2 also. X plus 5 times x, it will be x squared plus 5x, and then minus 50 divided by 2, which is 25, equals 0. So we will write here a equals 1, b equals 5, c equals negative 25, and then substitute in the general formula is x is equal to negative b, which is negative 5, plus or minus square root of b squared, which is 25, minus 4 times 1 times negative 25 will be plus 100, divided by 2a, which is 2, is negative 5 plus or minus 5 root 5 over 2. This is x, but the required is to get what? Is to get the height. The height is double of x. So the height will be double this. We will cancel this 2, and we can write 5 as a common factor. And of course, the negative will be cancelled. The length can't be negative, so the height will be double this value. We will take 5 as a common factor and start with the positive root here, minus 1, the same answer. Exercise 2c, question 4. Given that x squared plus x plus 6 equals x plus a all squared plus b, find a and b. Okay, now I will write bracket squared and then minus. Here I will write x plus half of the coefficient, which will be 3 over 2, minus squaring this quantity, which is 9 over 4, okay, and then plus 6 again, which can be simplified to be x plus 1.5 or 3 over 2 all squared. 6 minus 9 over 4 will be plus 15 over 4. Question 5, write 2 plus 0.8x minus 0.04x squared in the form like this. Okay, first of all, as I told you before, we should make the coefficient of x squared 1. So I will take negative 0.04 as a common factor here. then we have x squared. Okay, 0.8 divided by 0.04 multiplied by 10 here and here, it will be 8 divided by 4 over 10, which is 80 over 4, which is 20. Okay, 20x of course, and then keep plus 2 away, and then we will write negative 0.04 big bracket, and then small bracket x minus half of the coefficient, which is 10, all squared minus 100, close the big bracket, and then plus 2, expand again here, equals negative 0.04 x minus 10 all squared, and then we have plus, of course, 100 times 0.04 will be 4, 4 plus 2, we can write it 6, okay? And in this case, a will be 6, right? The number which is written here, and then b will be, the negative exists already, so I will write 0.04 only, plus c, so it will be negative 10. Very good. Exercise 2D, question 3, x squared minus 14x plus 1 equals, okay, complete square also. We will write it as the following. We will write for item A, x minus half of the coefficient all square minus 49, and then plus 1. Or we can rewrite it as x minus 7 all squared minus 48. So the value of p here, negative 7, and then q will be negative 48. B, using your answer to part A or otherwise, show that the solutions to the equation lie. Okay, very good. We will solve the equation but using completing square. So I will rewrite this equation by the completing square form, x minus 7 all squared minus 48 equals 0 all or equals 48, right? And then take square root of both sides. Then we have x minus 7 equals positive or negative, so it can be 4 square root of 3, and then x will be 7 plus or minus 4 square root of 3. Question 4. By completing the square, show that the solutions to the equation x squared plus 2bx plus c equals 0 are given by the formula like this. Very good. Okay, first of all, we will write this in the left hand side as x plus half of the coefficient. The coefficient is already 2b, so its half will be just b all squared minus this quantity squared, okay, and then plus c, 0. So I will keep here x plus b all squared. Taking the square root, we have x plus b equal positive or negative square root of b squared minus c, and finally move b to the other side. X will be negative b plus or minus square root of b squared minus c, right, as the required. Exercise 2e, question 2. The function f of x is defined by x squared minus 2x. X belongs to the real number. Given that f of a equals 8, find two possible values for 8. Okay, piece of cake, of course. F of a means replace each x with a. So a squared minus 2a equals 8, right? We can rearrange it to be a squared minus 2a minus 8 equals 0, and solving it for a, we will have here a minus 4 times a plus 2 equals 0. So either a equals 4 or a equals negative 2. Okay. Question 6. The function f is defined as f of x equals x squared minus x plus 2. X is a real number. Write f of x in the form, okay, computing the square, right? Okay. So we will rewrite f of x as the following. We will write this is a. Here I will take x minus half of the coefficient, which is 1 all squared, and then minus 1 plus 2. Simplifying here, it will be x minus 1 all squared, and then minus 1 plus 2 will be plus 1. The value of p is negative 1, and the value of q is just 1. B, hence means depend on your answer for part A, or otherwise explain why f of x more than 0 for all values of x, and find the minimum value. Very good. To answer this question, please concentrate with me here. The question said explain why f of x more than 0 for any value of x. Okay, of course we know that any quantity, we can start with this, any quantity, okay, squared should be post more than or equal 0. Equal 0 in the case of x equals 1. Okay, and for all other values, this quantity should be positive. Okay, and if we add 1 again here, if we add 1 also x minus 1 all squared, and then moreover we will add 1, of course it will be more than 0. And the minimum value here will be what? Will be 1 at x equal 1. Minimum value is 1 at x equals 1. Exercise 2e, the function f is defined as f of x equals 3 power 2x minus 28, 3 power x plus 27, x is real number. Write f of x in the form, okay, the question asks about factorization. And this is a very important question because we can rewrite f of x as the following: 3 power x all squared and then minus 28 times 3 power x and then plus 27. You should know that the quadratic expression is not only for x, but for any quantity. Our quantity here is 3 power x, okay? Sometimes it can be x power 2, so it will be x power 4 finally, minus 28x power 2, and so on. It can be sine x squared minus 28 sine x, okay? If we have this quantity, it's the same as this quantity, but we have squared here, we can apply the same idea of quadratic expression, okay? But not for x, for this quantity. So if we want to factorize it, it will be 2 brackets, and then for the first bracket I will write 3 power x here and 3 power x here, because 3 power x and 3 power x will be 3 power 2x as the question said. And here I will write minus 27, or minus 1 and minus 27. Their product is positive 27 and their sum is what? Is negative 28, right? This is for part A. For part B, the question said hence find the two roots of f of x. The means of roots equating f of x with 0. Okay, so for f of x equals 0, this means that either this bracket equals 0, 3 power x minus 1 equal 0, or 3 power x minus 27 equal 0. For the first case here, 3 power x equals 1, which means that x equals 0. For the second case, 3 power x equals 27, which is 3 power 3, which means x equals 3. Exercise 2f, question number 2. These sketches are graphs of quadratic functions of the form ax squared plus bx plus c. Find the values of a, b, and c for each function. Okay, the main idea here is that negative 3 and 3 are roots, are the solutions of equation f of x equals 0. h of x here will be x minus 3, okay, or x plus 3 times x minus 3, right? But the problem is that we don't know the coefficients. We can simplify it to be a times x squared minus 9, of course. X squared minus 9. But we have very important information, which is f of 0 is negative 18. F of 0 is negative 18. So replace x with 0, and the output should be what? Should be negative 18. So negative 18 equals, if x equals 0, it will be negative 9a, so a should be 2. So the function h of x will be 2x squared minus 2 times 9, which is minus 18. Okay, for the second item here, the same. I will do the same. Here, the function is g of x. G of x should be x plus 2 times x minus 5, because if you want to solve this equation, equating it with 0, to get the roots, it will be 5 and negative 2. But the problem is in the coefficient. But it will be very easy because we have a very important information, which is g of 0 is what? G of 0 is 10. So replacing x with 0 will give us 10. 10 equals, if x equals 0, this bracket will be 2. If x equals 0, this bracket will be negative 5, so negative 10a, and the value of a should be negative 1. So our function should be negative, and then expand these two brackets. X times x, it will be x squared, and then 2x, negative 5x, it will be negative 3x, and negative 10. So finally, it will be negative x squared plus 3x plus 10. Exercise 2f, question 3. The graph of y equals ax squared plus bx plus c has a minimum at 5 and negative 3 and passes through 4 and 0. Find the values of A and B. In the previous video, we talked about something called vertex form or turning point form from the quadratic equation. So we can write it as A multiplied by x minus h all squared plus k, such that h and k is the coordinates of the minimum point or the turning point. So we have the following: A multiplied by x minus h, which is 5 all squared, and then minus 3 as it is. We have now an extra information, which is y. If x equals 4, y equals 0, right? If x equals 4, y will be 0. So we can write here 0 equals 4 minus 5 negative 1 all squared will be 1 times a will be a minus 3. So the value of a should be 3. So the final answer will be as the following: y will be a, which is 3, times x minus h, which is minus 5 all squared plus minus 3. Expand it to put it in the general form: x squared times 3, 3x squared, negative 10x times 3, it will be negative 30x, and plus 25 times 3 plus 75 minus 3. So the final answer should be 3x squared minus 30x, and then 75 minus 3 will be plus 72, right? And if we want to solve it with another method, if we concentrate well, the axis of symmetry is at x equals 5. So when we draw the graph of this parabola, we have a minimum point at 5 and minus 3. Minus 3 is here. So this is the shape of the curve. F of 0, if we have x equals 4, y equals 0, right? So this point is 4. So as this is the axis of symmetry, so the other root here should be as the same distance as this distance, which means 6. Very interesting idea, right? So we have the two roots now, so we can write y as a multiplied by x minus 4 times x minus 6. Now we can use the minimum point to get the value of a. We can say that if x equals 5, y equals minus 3. So I can put, instead of y, negative 3, and substitute x with 5. 5 minus 4, 1, and 5 minus 6 is negative 1. So it will be negative a, which means a is 3. So expanding these two brackets and multiply by 3 again, the final answer should be as the following: x times x, x squared times 3, it will be 3x squared, and then negative 4x, negative 6x, it will be negative 10x times 3, it will be negative 30x, and finally plus 24 times 3 will be plus 72. I think it will be the same answer like this answer. Exercise 2g, find the values of k for which x squared plus 6x plus k equals 0 has two real solutions. So I prefer to write a, b, c, and here. A is 1, b is 6, and c is k. For this case, b squared minus 4ac should be positive, and so that b squared, which is 36, minus 4 times 1 times k, which is minus 4k, more than 0, moving 4k here. 4k should be less than 36, dividing by 4, so k should be less than 9. Question 3, find the value of t for which this equation has exactly one solution. The same scenario: a equals 2, b equals minus 3, and c equals t. And in this case, b squared minus 4ac should equals 0. So b squared here is 9. I can move negative 4ac to the right hand side with positive sign, and then multiply 4 times 2, 8t, right? So t should be 9 over 8. Very good. Number 4, given that the function f of x equals sx squared plus 8x plus s has equal roots also, find the value of the positive constant x, s. Okay, very good. The same scenario, we will write here the values of a, b, and c. A is s, b is 8, and c also is s. And in this case, b squared minus 4ac should be equals 0. So we can substitute here 8 will be 64. Moving this quantity to the other side with positive sign, 4 times s, it will be 4s squared, which means that s squared equals 16. So s will be positive or negative 4, but I think we will take the positive only because we have here a condition for s. 4. Question 5. Find the range of values of k for which 3x squared minus 4x plus k is equal 0 has no real solutions. Okay, the same scenario here also. A should be, a is 3, b is negative 4, and c is k. No real solutions corresponds to b squared minus 4ac less than 0, which means that negative 4 all squared, which is 16, minus 4 times a minus 4 times a times c, it will be minus 12k smaller than 0, moving this to here and dividing by 4, so I have 4 less than 3k, so k should be more than 4 over 3. Okay. Question 6. The function g of x equals x squared plus 3px plus this quantity where p is an integer has two equal roots. Find the value of p. Again, also a here is 1, b here is 3p, and c will be 14p minus 3. And then we can say that b squared minus 4ac should be 0. B squared means 9p squared here, 9p squared minus 4 times a, which is 1, times c, which is 14p minus 3 equals 0. Expanding, we will have 9p squared minus 56p, and then plus 12 equals 0. P minus 6 times 9p minus 2 equals 0. Either p equals 6 or p equals 2 over 9, but I think p should be what? Should be integer, right? Yes, integer. So we will accept this solution only. Okay. 7. H of x equals, where k is real constant. Find discriminant of h of x. Okay, again, also we have here a equals 2 and b equals k plus 4 and c equals k. So the discriminant is b squared minus 4ac, which is k plus 4 all squared. It will be minus 4 times 2 times k. So it will be k squared plus 2 times first times second plus 8k plus 16 minus 8k also minus 8k. Okay, nice. We can simplify negative 8k with positive 8k. So the answer should be what? The discriminant should be k squared plus 16. B, hence or otherwise prove that h of x has two distinct real roots for all values of k. As we said before, k squared should be more than or equal 0. And if we moreover add a quantity, a positive quantity for it, it will be, of course, it will be more than 0 for all values of what? Of k, which means that b squared minus 4ac, because this is the discriminant, should be more than 0, okay, which corresponds to two real solutions. So to review question 3, f of x equals and g of x equals, where k is constant. A, given that f of 3 equals g of 3, find k. Very good. F of 3 means 3 squared 9, 9 plus 3 times 3, which is 9 also, minus 5 equals to g of 3 here. 4 times 3 is 12 plus k, right? 9 plus 9, 18, 18 minus 5, 13. So 13 equals 12 plus what? Of course, plus 1. K equals 1. This is the first part. The second part here, find the values of x for which f of x equals g of x. Okay, f of x is x squared plus 3x minus 5 equals g of x, which is 4x plus k, and k is 1. So rearrange and solve. You can find the solution like this. X equals 3 or x equals negative 2. Question 6. Find the value of k for which the equation has exactly one solution. A here is 5, b is negative 2, and c is k. So this case, exactly one solution corresponds to b squared minus 4ac equals 0. B squared, which is 4, equals 4 AC, 4 times 5, 20 times K, 20K, dividing by 4, or you can say 4 divided by 20K is equal to 1 over 5. 7, given that for all values of X, this expression would be like this, find P and Q. Of course, it's a computing square question. Okay, take 3 as a common factor at first, and then we have x squared plus 4x, and keep 5 away, right? Then equals 3 big bracket small bracket squared minus, okay, here I write x plus half of the coefficient, which is 2, and here minus 4, and then plus 5 here. Expanding again, it will be 3 times x plus 2 all squared minus 12 plus 5, it minus 7. B, hence solve the equation. Okay, to solve the equation, I can put it equal 0 and move negative 7 to the other side. So it will be 3 times x plus 2 all squared equals 7. Then dividing by 3, it will be x plus 2 all squared equal 7 over 3. Taking the square root, it will be finally, we can say x equals negative 2 plus or minus square root of 7 over 3. Question 8, the function f is defined as, okay, very good. Write f of x in form, okay, we solved before a question similar to this question. We can factorize it easily by writing it as the following. We can write 2 power x here and 2 power x here, because 2 power x times 2 power x will be 2 power 2x, and then we can write here minus 4 times minus 16. Their product is 64 and their sum is negative 20. This is f of x. And for b, find the two roots of f of x. If we equate it with 0, okay, either the first bracket will be 0, which means that 2 power x equals 4, which means x equals 2, or the second bracket is 0, which means 2 power x equals 16, which means that x equals 4. Question 11. A diver launches herself off a springboard. The height of the diver in meters above the pool t seconds after launch can be modeled by the following function. It's a very interesting problem. Now we have an application. H of t is equal to 5t minus 10t squared plus 10t more than or equal 0. This is a very useful relation, which means if I give any instant, any time, we can get the height of the diver. It's very nice. The time axis and the vertical axis to be the height, right? And the diver will jump like this. So to answer part A, how high is the springboard above the water? It's very easy. The question asks about this height, which is corresponding to t equals 0. Very simple. So we write at t equals 0. Look at the equation. H of 0 equals what? 0 minus 0 plus 10. So h of 0 is 10, which means the springboard will be 10 meter above the water level. Okay, for B, the question said use the model to find the time at which the diver hits the water. Very good. When the diver hits the water, he will be here, right? Which means that h itself is 0. The height is 0. So h of t equals 0. 5t minus 10t squared plus 10 equals 0. We can divide it by negative 5 to be 2t squared, and then minus t, and then minus 2 equals 0. In this case, t will be approximately equal 1.28 seconds, and the negative solution will be cancelled because the time should be positive. C, rearrange h of t into the form. Okay, the required is to complete the square. Very good question. To complete the square, as we know, we should take negative 10 as a common factor. So h of t should be as the following: negative 10 as a common factor, and then I will have here t squared. 5 divided by negative 10, it will be negative half, right? Negative half t, and then keep plus 10 away. Very good. And then we can rewrite it as negative t, big bracket, and then small bracket, t minus half with the coefficient, which will be quarter, all squared. and then minus 1 over 16. Close the big bracket and then plus 10. Very nice question. And then it will be negative 10 times t minus quarter all squared, negative negative plus 10 over 16, which can be simplified to 5 over 8, and then plus 10. Simplifying these two terms. After simplifying, the answer will be 10.625 minus 10 times t minus 0.25 all squared. So the value of a here is 10.625. We have minus after that, and so that b is 10 and c also will be 0.25. The final item here, d, using your answer to part c or otherwise find the maximum height of the diver and the time at which this maximum height is reached. Of course, we know that for answering here, we can say at t equals quarter second, at which this value will be, this expression, this bracket will be 0. The maximum height, h maximum, will be 10.625 meters. Very nice question. Question 12. For this question, if x equals 4kx squared plus bracket 4k plus 2x plus 1, k is real constant, find the discriminant. Discriminant is b squared minus 4ac, which here will be b is 4k plus 2, 4k plus 2 all squared minus 4a, which is 4k, okay, and c, which is 1. After it will be 16k squared plus 4. B, by simplifying your answer to part A or otherwise, prove that if x has two distinct real solutions for all non-zero values. Okay, of course we know that k squared should be more than or equal 0, and so that 16k squared plus 4 should be more than 0, which means that b squared minus 4ac more than 0, which means that for all values of k the function has, we have two distinct real roots, and then explain why f x cannot have two distinct real roots when k equals 0. If k equals 0, look at the first line here. If k equals 0, f of x will be what? Will be without k here, 0, and then it will be, I think, 2x plus 1, right? 2x plus 1, which is what? Which is linear function. Linear function means that we have linear function, which means that we have only one solution. Find all the roots of the function. Very good. We can write it as x power 4 times x power 4, because x power 4 times x power 4 will be x power 4 plus 4, which is 8. And then we can write here minus 1 and minus 16 equals 0. So either x power 4 equals 1, which means that x equals positive or negative 1, or x power 4 equals 16, which means x equals positive or negative 2. Okay. Thank you for watching and see you in the next chapter. Goodbye.